Hello and welcome to the last video on permutations and combinations. Today, the topic is permutations in a line, which is basically permutations of people, objects, and so on. We're going to talk about that. Let's start discussing how these questions will be solved. Again, I'm going to use the same idea since this is about permutations. I'm going to be drawing dashes in a lot of cases, and then sort of using both factorial and at times NCR to solve these questions for you. Okay. The first question says a team of three boys and three girls is to be chosen from a group of 12 boys and nine girls to enter a competition. Tom and Henry are two of the boys in the group. Find the number of ways in which the team can be chosen if Tom and Henry are either both in the team or not in the team. So, chosen is the word that I am looking at right now, and that tells me that this is not a question on permutations. This is a question on combinations, and let's solve it in the way that we've learned it before. Okay. So boys, girls, and there's Tom and Henry who don't want to be together. So Tom, Henry, other boys, and girls. Okay. So a team of three boys and three girls. So three boys and three girls. Tom and Henry are one, and there are 12 boys in total. So 10 boys here and 9 girls here. I want either Tom and Henry to be both in the team or both not in the team. So they can either be both in the team. So there's one more boy that I need to select, and three girls, or both not in the team. There's going to be 1C1 into 1C1 into 10C1 into 9C3. Then 1C0 into 1C0 into 10C3 into 9C3. Two different cases that I have. Let's quickly calculate them. 10 into 9C3 gives me 840, and 10C3 into 9C3 gives me 1080. Together they gave me 10920. Yes, that is indeed the correct answer. Now let's look at the next one very carefully because this is going to build up the base for a lot of other questions that are going to come up. Part B says the back row of a cinema has 12 seats. The back row of a cinema has 12 seats, all of which are empty. A group of 8 people, including Mary and Francis, sit in this row. Find the number of different ways that they can sit in these 12 seats if there are no restrictions. Okay. So what I'm going to do is I'm going to say that there are 12 seats. There are different ways of doing this question. Just remember that. Okay. But only 8 people are there. A group of 8 people, including Mary and Francis, sit in this row. Find the number of different ways that they can sit in these 12 seats if there are no restrictions. So whenever people are coming in and choosing their seats and then sitting on them, what you should remember is that this is a merger between permutations and combinations. What I'm going to say is that out of these 12 people that are there, what happens is that these 12 people come in, they choose 8 seats that they want to sit on, so different combinations of seats, and then they sort of arrange themselves. How do you arrange 8 people? You say there are 8 factorial arrangements. Okay, that's one way of doing the question. I am pretty sure the answer is going to be 1995840. I could get the same answer from a different method as well. I could say that these 12 seats can shuffle around between themselves. Okay, so I'm going to say 12 factorial ways. Maybe 8 people are sitting here and there. I don't know where they're sitting, but let's say these seats are numbered A, B, C, D, E, F, G, and I can sort of shuffle them around and say that there are 12 factorial ways of doing it. But I should remember that 4 of those seats remain empty. Now, the empty seats are identical to one another. Why? Because on the rest of the seats, people are sitting. Okay. So if they are identical to one another, what I can say is there are 4 identical seats remaining. So I divided by 4 factorial like I used to divide in permutations and combinations. I'm going to use these methods interchangeably in questions. So I want you to be aware of both of them. Okay, I'll figure out whichever way is easier to explain and I will do that. Let's look at part 2. It says Mary and Francis do not sit in seats which are next to each other. So what I could do first is I could put them together in a box and subtracted from not together, from unrestricted combinations, the answer in part 1, I could do that. Or there is another method that I want you to learn now. Okay, whenever you want to separate two things or three things or four things, what you need to do is learn the arrow method. Okay, what is the arrow method? What happens is that there are 8 people who want to sit. Okay, I think the better way of explaining this question would just be to subtract. I think because there are too many empty seats, I'll get confused when I am talking about empty seats. So it's best to just do 199,584,000 minus together. How do you keep anything together? You draw a box around it. Mary and Francis, how many other seats? There are 10 other seats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to say that this is 199,584,000. The box acts as a dash. There are 11 dashes outside, so 11 factorial. You go inside the box, that's 2 factorial. Okay, inside the box there are 2 dashes, therefore 2 factorial. Are there any identical? Yes, obviously there are 4 seats remaining, therefore 4 identical seats. Let's see if we get the correct answer with this method. Yes, 16632332000. I'm going to teach you the arrow method in a bit in the next question, hopefully. Then it says all 8 people sit together with no empty seats in between. So when they want to sit together, what you simply do is you put them in a box. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4. Okay, the box acts as a dash. So 5 factorial multiplied by 8 factorial. Okay, divided by 4 factorial because I'm still shuffling around those empty seats that were there. Okay, so make sure that you understand this, and we have our final answer hopefully, and it should be 5 factorial into 8 factorial divided by 4 factorial. 201600. So that was the easy way of solving this. Let's look at the next one. It says 4 families go to a theme park. Mr. and Mrs. Lin take their 2 children. Okay, Mr. and Mrs. Lin, 2 children. Mr. O'Connor, 2 children. Mr. and Mrs. Ahmed, 3 children. Mrs. Burton, 1 child. The 14 people all go through a turnstile one at a time to enter the theme park. In how many different ways, different orders can the 14 people go through the turnstile if each family stays together? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Each family stays together. The first one family has 4 people, so I put a box on 4. The next family has 3 people, so I put a box on 3. The next family has 5 people, so I put a box on 5. And the next family has 1 person, 2 people. I put a box. Every box acts as a dash, so 4 factorial. Then you go inside the boxes. The first box has 4 dashes, so another 4 factorial. Then you go inside this box, 3 factorial. Then you go inside that box, 5 factorial. You go inside that box, 2 factorial. Are there any identical things? No, there aren't any identical things. People can't be identical. So that is pretty much it. You get your answer by multiplying all of these through, and you should get into 829440. Okay, I'm going to check the answer quickly. Yes, that is the answer that you have. Then says how many different orders can the 8 children and 6 adults go through a turnstile if no 2 adults go consecutively? Now this is an important question and I want you to learn a few things here. What I'm now talking about is that the adults are separated, so the adults are not going together. So whenever you want to separate something, what you do is you take the other thing and you put the dashes down. How many children? 2 plus 2 plus 3 plus 1. That gives me 8 children. Okay. How many ways are there to shuffle these 8 dashes? I'm going to say that there are 8 factorial ways. So the children are going, they are shuffling around between themselves, they have their positions, okay, and they are going through the turnstile. But remember that in this question, I have to separate the adults. So the adults can go at this point, 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 and at this point. So arrow method. I have put down arrows on where the adults can appear. How many arrows have I put down? 1, 2, 3, 4, 5, 6, 7, 8, 9. Are there 9 adults? No, there aren't 9 adults. There are 2, 1, 2, and 1. There are 6 adults only. So they can choose whichever position they want to go into. As long as they are following these positions, they will be separating themselves. That's the objective of the question. So I'm going to say that this becomes 9C6. They choose their position and then they arrange themselves. As of course, they can, sort of shuffle around between themselves if Mr. O'Connor wants to go first or Mrs. Ahmed wants to go first and so on. But they've chosen which arrow they want to go into. Okay, so that's 6 factorial. Do I divide by something? No, I don't divide by anything. So I've arranged the children, I've arranged the adults as well. There was a little choosing in the adults as well. So I've done all of that, and now I'm going to say that this is a huge answer: 24385536600. Okay, and that's sort of rounded off to 3 significant figures and written down for you in terms of a standard form. That's your choice, it's not necessary. Then it says once inside the theme park. So remember that which the last part was to teach you how to separate things when you don't want them to go together or appear together. Then it says in how many different ways can the 8 children be divided into 2 groups of 3 and 1 group of 2 to go on the roller coaster? So I think that's simple. 8 children, so 2 groups of 3. So the first group is chosen 8C3. There are people separated into the first group. Leftover people 5C3, and 5 people are left over. Another group of 3 is chosen, and the remaining people go into 2C2. Okay, and that's the final answer. 560. Okay, so they were no longer arranging themselves or anything, they were just splitting into groups. So I've split them into groups and made it very simple. Okay, let's move on to the next question. These are common. You often have buses made for you, and then you need to figure out where everyone's going to sit. A minibus has a seat for driver D and 7 passengers is shown. When 7 passengers are seated in a random order, find the probability that the 2 particular passengers, A and B, are sitting on the same side of the minibus. Okay, so whenever you're doing probability, the first thing to do is what the denominator would be. The denominator is always the set of unrestricted outcomes. So I could say that there are 7 people, so their denominator should always be 7 factorial. Now let's decide if they are on the same side of the minibus, which means that A and B should first either be sitting on this side or that side. Okay, we'll make 2 different cases. Let's say they are sitting on the side that appears at the bottom first. Okay, there are 3 seats. What A and B could do is they could choose 2 seats out of 3 and they could arrange themselves. Okay, the rest of the seats are left over. How many seats are left over? There are 5 seats left over, so the remaining 5 people seat themselves. Okay, so that's the first case where they are sitting at the behind the driver. Let's say they don't want to sit behind the driver and they're on the opposite side. There are 4 seats available there. They first come in and choose their seats. Okay, and then the remaining people also choose their seats. And then this divided, that's divided by 7 factorial, because I am calculating the probability in this case. Okay, so 3 over 7. They are on opposite sides of the minibus. I think that's very simple. If they are the same side has a probability of 3 over 7, then the opposite must have a probability of 4 over 7. Okay, that pretty much solves the question. Okay, let's look at the next question. It says three identical cans of cola, two identical cans of green tea, and two identical cans of orange juice are arranged in a row. Calculate the number of arrangements if the first and last cans in the row are of the same type of drink. Okay, so 3, 2, and 2. It's a roll of 7. Okay, so if there are identical drinks on the first and last cans are the same type of drink, so either they could be cola and cola, or they could be green tea and green tea, or they could be orange juice and orange juice. Okay, so if they are cola and cola first, the remaining dashes are 5. So I'm going to say that there are 5 factorial ways of shuffling them around. Are any of these things identical? Yes, there are lots of things identical inside. There was one can of cola left, so that's not identical. Two green tea cans and two orange juice cans. Then when I'm doing this, I'm going to say that again there are 5 dashes in the middle. Okay. Now what is identical? 3 cans of cola and 2 cans of orange juice. When I'm doing this, again 3 cans of cola and 2 cans of green tea in this case. So there are different answers for different ones. So 120 divided by 4 gives me 30. 120 divided by 12 gives me 10 and 10. So 30 plus 10 gives me 50 arrangements. Okay, a relatively simple question. Then it says the cans of cola are all next to each other and the 2 cans of green tea are not next to each other. So both restrictions. I want to separate something and I want to keep something together. So when whatever I want to keep something together, I should put that in a box. Cola, cola, cola. Okay. And then green tea are not next to each other. So I will not mark them as dashes. I will mark them as arrows then. Okay. So 1 and 2, orange juice. Okay. Box acts as a dash. So 3 factorial first. Then you go inside the box, you say another 3 factorial. The first 3 factorial is for 2 dashes and the dash below the box. Okay. Then you decide where you want the green colors to be, green tea to be. There are 4 different places where I could put the green tea. How many green teas are there? There's just 2 green teas. So 4C2 into 2 factorial, the green teas will also arrange themselves. I have not considered the fact that these were all identical things. So I'm going to start dividing first by 3 factorial because 3 cans of cola, then by another 2 factorial because 2 orange juice, and then by green tea because 2 green tea. Okay. So whenever I'm arranging identical things, I need to divide. So I get 18. That brings us to the end of this series. This was on 4 different videos. Make sure that you understand all the different cases. Now, whenever you are trying to attempt past paper questions, remember the strategies that I've taught you. I've kept them very distinct in terms of letters and digits and then objects and lines and everything. So make sure that in your head, whenever you are trying to do a permutations and combinations question, you filter out that question first and then move on. Okay, thank you for watching. I will try to record some more videos on some recent questions in the next few days. Thank you for watching.